Hello everyone, in this video lecture let's understand mathematical analysis of non-recursive algorithm by taking an example. So before taking an example, we'll see the general plan for analyzing the time efficiency of non-recursive algorithm. So mathematical analysis is used to find the time efficiency. Okay, so the first step in the general plan is decide on a parameter or a parameters indicating an input size. So first you need to understand the parameter on input size. Okay, next identify the algorithm's basic operation. So normally basic operation is specified within the innermost loop. Okay, check third step, check whether the number of times the basic operation is executed, whether it depends on the size of the input or not. Okay, and based on that we can categorize worst case, average case, or based on we can decide worst case, average case, and the average case and the best case of a algorithm. Next, set up a sum expressing the number of times the algorithm's basic operation is executed, and finally use the standard formula or a rules of sum manipulation to find the to set up a time efficiency. Okay, these are the 5 steps. First step is, let me repeat, the first step is decide the parameter that indicates the input size. Second one is identify the basic operation. Third one is check whether the number of times the basic operation is executed, and the fourth one, set up a sum expressing the number of times algorithm's basic operation is executed. Fifth one, use the standard formula and rules of sum manipulation to decide the time efficiency. So now I will consider an example. Okay. So here I am going to consider the problem of finding the value of the largest element in a list of n numbers. For simplicity, we assume that the list is implemented as an array. The following is a pseudocode for a algorithm. So first we need to write an algorithm. So I'm using the pseudocode convention. So throughout I'm using the pseudocode convention to write an algorithm. So here largest element in a list of n numbers. So first line is algorithm, the name of the algorithm, and the parameter. Parameter here is list of n number. From an array of elements you are finding the maximum element. So first aim of the element determines the value of the largest element in a given array. Next, input an array a of 0 to n minus 1 of real numbers. Then output the value of the largest element in a array, and then the procedure or body of a algorithm you need to write. So max val a of 0, initially the first array element, let me take a 2, 3 and 5. Okay, let me take a 3 elements in an array. Okay, 3 elements in an array. So a of 0 is this value, you know that this is an array a. 0, a of 1 is this element, a of 2 is this element. Okay, initially max value is the first element. I'll let you, the first value is the max element. After that I'll be comparing this max element with the remaining elements. Suppose if I get a greater element than the maximum value element, then I will change the maximum element as the greater element. Okay, so for I equal to 1 to n minus 1, this is the 0th location, this is the first location, and n minus 1 is this location. So 1 to n minus 1, you keep checking the array or keep comparing the array elements with the max value element. So a of I greater than max value, then max value equal to a of I. So if a of I greater than max value, then max value equal to a of I. Max value will be a of I. So here a of I is a of 1. Initially I equal to 1. So 3 is greater than max value. 3 is greater than max value. What is max value element initially? 2. So that means max value equal to a of I. So max value now becomes 3. Again I equal to 2 now. So remember, max value is now 3. It's not 2 anymore. So I equal to 2. Then again a of 2 I 5. A of 2 is greater than max value. Whether it is true? Yes. A of 2 is 5. That is greater than max value. So max value now becomes 5. 5. Then I equal to n minus 1 is done. We can't read more elements. This is it, because 1 to n minus 1. Total there are 3 elements. N is 3. So till 2 you can go. Finally return max value. Max value is 5. So I am returning the final max value. Now we'll see the time complexity of max element algorithm. First of all, the first step in finding the time efficiency of a non-recursive algorithm is measure of input size. Here it is the number of elements in the array. You can see here the input size is the number of elements, that is n. Okay. Next step, the second step is identify the basic operation. How do you identify the basic operation? It is normally lies in the innermost loop. So the loop here is for statement. Okay, so there are 2 operations you can see inside the for loop. One is a of I greater than max value. Another one is max value is assigned with a of I value. There are 2 statements. So which is executed most number of time? Which is executed most number of time? That is a of I greater than max value. That is executed most. So we can say that comparison is the operation, basic operation, because it is executed more number of times. Okay. The third step is, the first step is the measure of input size. The measure of input size is n, and then the identify the basic operation. So the basic operation here is comparison, as it is executed more number of times and which lies within the innermost loop of the algorithm. Third one is find the number of times the basic operation execution, whether it depends only on n. So the third step is check whether the basic operation executed depends only on n. Basic operation executed depends only on n. Is there any additional property? On only n. So in this case, yes, it is not dependent on any other additional property. So basically it depends only on the n. So as the number of time, that is as you read the number of elements, so it is going to execute. So it depends only on n. There is no additional property. If suppose it depends on other additional properties, then you need to find the time efficiency according to worst case, best case and average case. Since it depends only on n, so you do not find all those cases. Okay. The fourth one is set up a sum expressing the number of times basic operation executed. So we can, I am representing the basic operation as C of n because it depends on n. So how many number of time basic operation executed inside the for loop? One time. Okay, the step count for this is 1. So summation equal to 1 to n minus how many number of times? That is, this will execute once for each iteration. So that iteration is I equal to 1 to n minus 1 time. So totally we can say that it is n minus 1 u minus L plus 1 u minus L plus 1. So n minus 2 plus 1, that is n minus 1. So which belongs to theta of n. So let me tell you the formula I have applied here. The formula what I have applied here is summation of I equal to L lower bound to upper bound. If this is a formula, if this is a sum, then what's the formula? U minus L plus 1. U minus L plus 1. U is n minus 1. This is U. This is L lower bound. L minus L plus 1. So we get n minus 1, which, so n minus 1 belongs to theta of n. So n minus 1 can be directly written as theta of n. Next we'll see another example. Before moving on to the another example, let's note the formulas. We use especially frequently two basic formulas, basic rules of sum manipulation. One is summation of I equal to 1 to u is not is C, some constant AI will be equal to C. You can see that this particular part of the formula, a part of the sum manipulation depends on the I. So that will be kept inside the sum. So C can be kept out because it is a constant. It is not dependent on I. So C can be kept out. Okay. Next we have one more I equal to 1 to u AI plus or minus BI, which can also be specified as summation I equal to 1 to u AI plus minus summation I equal to 1 to u BI. Okay. Next we have two more summation formulas which I've already explained in the previous exam. Summation I equal to L to u is of 1 is nothing but u minus L plus 1, where L and u are lower and upper integer limits. Then if you have a formula like this, sum, that is sum manipulation like this, I equal to 0 u upper bound, sorry n, then I, if it is of this type, then we can write this as I equal to 1 to n I equal to 1 to n I, which is equal to 1 plus 2 plus n, because I, for I you can keep applying the value from 1 to n, lower limit to upper limit. So 1 plus 2 plus 2 n. Okay. So which is equal to n into n plus 1 divided by 2, approximately equal to half n square. So we can write this as belongs to theta n square. Let's here consider another example, that is element uniqueness problem. What we are checking here, we are checking whether all the elements in a given array of n elements are distinct. So Let's read the first line of the algorithm, that is algorithm heading. Says that algorithm unique elements a of 0 to n minus 1. A of 0 to n minus 1. Now the second first three lines are, after that first three lines are the comments. The first line says the aim of the program, that is determining whether the elements in a given array distinct. Second one is input. Input is the array element, so a of 0 to n minus 1. Output is the returns true if all the elements in A are distinct and false otherwise. Now let's understand the main part of the algorithm. So that's why I will take a n array elements, n equal to 4, 0, 1, 2, 3. So the locations here are 0, 1, 2, 3. So name of the array is A. So the elements in the array are 1, 2, 3, 4. Okay, let me assume the elements in the array are 1, 2, 3, 4. So the location is 0, 1, 2, 3. So let's check how exactly we are checking. So my aim is to check, that is compare the first element with the remaining element. First element, that is a of 1 with the, so not a of 1, a of 0 element with the remaining element. So when I is 0, I am comparing with j equal to 1 element, first element, second element and third element. Okay, when I is 1, I am checking with the remaining two elements. Okay, when I is 1, that means I am comparing a of 1 element with the remaining two elements. So j can become 2 and j can become 3. Finally, when I is 2, there is only one element to be compared, remaining to compare, that is a of 2 with the a of 3. Okay, so j is 3, now I is 2. Next, so I can say that outer loop I can go from 0 to 2. So that's why I am writing for I equal to 0 to n minus 2. If n is 4, then it is 2. Okay. Next, the innermost element can go from 1 to, that is always if I is 1, then j will start from 2. If I is 0, j will start from 1. If I is 2, j will start from, if I is 2, then j will be starts from 3. So that means always j will start from I plus 1 to n minus 1. Okay, that is what the first two lines. And here, if in case any element is equal, then we can decide that it's not a distinct element. If it is equal, then you're going to return false. Okay, if the all the array elements are distinct, then it's going to return true. Okay, so if a of I equal to a of j, return false, else return true. Okay, any of the array elements are equal, then you're going to return false. So now let's find the time efficiency. Let's find the time efficiency for this algorithm. As usual, the first step. What's the first step? The measure of the input size is, here again it is n. Measure of input size is n. Okay, again the number of elements in the array. Second one, identify the basic operation. Second step says that identify the basic operation. How we are identifying the basic operation? Basic operation normally lies in the innermost loop. Innermost loop is this, it's inside this. You have to identify the basic operation, and remember, while identifying the basic operation, that has to execute more number of times. The operation that is being executed more number of times. So here the comparison again. So the basic operation is comparison, because if a of I equal to a of j, that executes more number of times. Okay, next. Now third one, we have to check whether that is this basic operation depends only on n or not. Depends on n or not, that is input size or not. So here if you check, the basic operation is not depends only on n, but also on whether there are equal elements in the array. There are equal elements in the array. Okay, if there are, then which array positions they occupy. Okay, so that is why here what I can tell, this basic operation not only depends on n but on the other characteristics also. Okay, that is other characteristics in the sense, if the elements are equal, then it behaves differently. So that means the basic operation depends not only on n, there are other characters here is that the comparison of equal elements. If the algorithm gets the equal element, then there itself it's going to stop comparing the further elements. Okay, so that is the additional characteristics the algorithm depends. Okay, now since it does not depend only on n, so we need to find the several cases, that is average case, best case and worst case. But here I am going to find the time efficiency only for a worst case of n. See worst of n, only worst case of a comparison. So now here the comparison is this. So how many number of times it can go? At the max it can loop until I equal to 0 to n minus 1 and j equal to I plus 1 to n minus 1. Then let me set up a sum for that. I equal to, outermost loop is I equal to 0 to n minus 1 to j equal to I plus 1 to n minus 1, and each time it executes once. Okay. Now let me solve this portion first. So as usual, this is equivalent to the formula summation I equal to L U 1 lower limit upper limit, which is equal to L minus U plus 1, sorry, U minus L plus 1. Now this is equal to I equal to 0, n minus 2 to n minus 1 minus upper limit lower limit I plus 1 plus 1 plus 1, which is equal to 0 to n minus 2, then n minus 1 minus I minus 1 plus 1. So summation of I equal to 0 to n minus 2, which is nothing but minus 1 plus 1 can be cancelled. So it is n minus 1 minus I. Now this portion is not dependent on I, whereas this portion is dependent on I. So let us split it. I equal to 0 to n minus 2 n minus 1 minus summation of I equal to 0 to n minus 2 I n minus 2 I. Next, this is nothing but n minus 1. I can put it out as there are no part of this portion is dependent on I. So summation of I equal to 0 to n minus 2 1 minus summation of I equal to 0 to n minus 2 I. So this formula is similar to this, but here n is n minus 2. So we can write it as n minus 2. N is replaced by here n minus 2. So n minus 2 plus 1 divided by 2. So what about this now? This is nothing but n minus 1. Next, upper limit n minus 2, lower limit 0 plus 1. So minus n minus 2 n minus 1 divided by 2, which is nothing but n minus 1. And this is also n minus 1, so I can write n minus 1 whole square minus n minus 2 n minus 1 divided by 2. Now still if I solve, what will happen? So n square minus 2n plus 1. So here n into n square minus 2n minus 1, so minus 2n minus 1n, so minus 3n plus 2 divided by 2. So now this is equal to, let us make a common denominator as 2, so 2n square minus 4n plus 1 plus 2, not 2, because 2, if I make it common denominator, then it will become 2. This is 4n, this is 2, minus n square plus 3n and minus 2 So next, 2n square minus n square, so n square minus 4n plus 3n, so n plus 2n plus 2 minus 2, that is 0, divided by this, so which is nothing but n into n minus 1 divided by 2. Okay, so this is nothing, so which is approximately equal to half n square, because you can see that this is n square minus 1, so approximately upper limit can be half n square, so which belongs to theta of n square. So this is the time complexity of unique elements algorithm. Next we'll see another algorithm, that is a matrix multiplication. So input matrix, what I'm going to consider is A and B, whose order is of size, whose size is n cross n. So now algorithm matrix multiplication. So there are two matrices, input matrix A and B. Finally, the result need to be stored in the C matrix. Okay. Input size. First of all, input size is a matrix order n cross n. Then let's identify the basic operation, that is here multiplication. There are two arithmetic operations in the innermost loop here. They are multiplication and addition. So, but here we are considering the multiplication operation. Okay. So by a basic operation here is multiplication. Then let us set up a sum. M of n equal to summation of I equal to 0 to 1 to n is this multiplication operation will be performed so many times because there are three loops. One, I equal to 0 to n minus 1, then the next loop is j equal to 0 to n minus 1, and the third loop is k equal to 0 to n minus 1. So at a time this will execute once. So summation of I equal to 0, j equal to 0 to n minus 1 and 1. Okay. Next, if we solve this portion, we are going to get n. So that n, if I put it out, finally I am going to get again summation of I equal to 0 to n minus 1, summation of j equal to 0 to n minus 1, 1. So if I solve this portion again, this portion is similar to this portion. This portion while solving I got n. So even if I solve this, I am going to get n. So one more n I am getting. So totally it becomes n square. Finally summation of I equal to 0 to n minus 1, 1. Outermost for loop that I am going to solve. So that also gives me n. So which is equal to n cube belongs to theta of n cube.